Welcome back. Today we're going to change the subject a little bit, and it's chapter 14, and it's about fluids, fluids and elasticity. So in this chapter, you will learn about systems that flow and deform, or flow or deform. Okay, so by the end of this chapter, you will be able to state the different phases of matter, describe the characteristics of the phases of matter at the molecular or atomic level. You will learn more about this in the next semester when you do thermodynamics, but we'll talk about it a little bit. You will describe or distinguish between compressible and incompressible materials. For example, fluids are not very easily compressible, but gases are easy liquids are basically incompressible, but gases can easily be compressed. You will define density and its related SI units. You will compare and contrast the densities of various substances. You will define pressure and its related SI units. So what's pressure? Explain the relationship between pressure and force. Calculate the force given the pressure and area. Define the gauge and absolute pressure. You will explain different methods for measuring pressure. Because remember, physics is an experimental science, and you cannot talk about quantity unless you know how to measure it. Okay? You will understand the working of open tube barometers. You will describe in detail how manometers and barometers operate. You will be able to state Pascal's principle. You will describe the applications of Pascal's principle. You will derive the relationship between forces in a hydraulic system. You'll be able to define the buoyant force. You will be able to state Archimedes' principle. By the way, so far, Archimedes and Pascal, these are the first basically two topics. They're called hydrostatic. The fluid will not be in motion yet. Okay? You will be able to describe the relationship between density and the Archimedes principle. And now the fluid starts to flow. So you'll be able to describe the characteristics of flow. You will be able to calculate the flow rate. You will describe the relationship between flow rate and velocity. You will be able to explain the consequences of the equation of continuity to the conservation of mass. You will explain the terms in Bernoulli's equation. You will explain how Bernoulli's equation is related to the conservation of energy. In fact, we will derive Bernoulli's equation from basically the laws of conservation of energy and Newton's laws, so math and Newton's laws. You will perform some calculations using Bernoulli's principle. You will describe some applications of Bernoulli's principle. You will describe the concepts of stress and strain in describing elastic deformations of materials. You will explain the limit where a deformation of a material is elastic. Describe the range where materials show plastic behavior. You will analyze elasticity and plasticity on a stress-strain diagram. And that's the end of chapter 14.